All right, section 6.6 we'll move into now, which is solving rational equations. So before we get into solving rational equations, let's look at some of these warm-ups here. Go ahead and see what you can do with these. I'll give you a hint on number 3. This is the long one. Remember the 7-step process that we discussed from section 6.2, where you're adding or subtracting rational expressions? You need to utilize those 7 steps here for number 3. So go ahead and pause and see how you can do on these warm-ups. Okay, so go ahead and check to see how you did. Number 1, you need to get a common denominator first. So once you did that, you can combine your numerators. You get 5x over 4. Number 2, this is very good to note what we're doing here in number 2 because we are solving equations today. And we're going to do it the same way we solved this one here. So first we cleared fractions. I multiplied through by 4, which was the LCD. So basically all terms get multiplied by 4. All of these denominators should divide evenly into 4. So 2 goes into 4 2 times, so you're left with 2x. Here the 4's cancel completely. You're just left with 3x, and then you're left with negative 5 by itself. So continue solving, you get x is negative 1. Number 3, the 7-step process. First you factor all of your denominators. So we have to factor this using the difference of 2 squares. Then we identify our LCD, which is x plus 5 times x minus 5. Then we make all of these denominators look like that. The x plus 5, x minus 5, distribute the 2, distribute the 1, combine it to be a single rational expression. Combine your like terms, look to see if this factors more, which it doesn't. Okay, this process is a little bit longer than what we're doing today. It's actually more difficult. And I will show you exactly the main difference whenever we get to example 5 today is this plus becomes an equals. So then we have a rational equation, and I show you what we do differently to solve that. It is actually less work. So what is a rational equation? It's an equation that contains one or more rational expressions, which is what we've been working with. So the way that we solve these is we multiply both sides by the LCD. Basically what we did in warm-up number 2, how you multiply through by the LCD. When clearing fractions, be sure to multiply every term in the equation by the LCD, and then you solve the resulting equation. Make sure you always check your answer because sometimes you get extraneous solutions, and we will see that. So looking at example 1, we look at our denominators, 3, 6, and x. And we just multiply both sides of the equation by the LCD, which is 6x. All of these denominators divide evenly into it. Now, if you want, you can write a 6x next to each term, like this. And since the 6x is over 1, it's basically going to go up in the numerator. You could multiply the numerators first and then divide, but I like to divide first. So 6x over 3 is 2x. 2x times 2 is 4x. Minus 6x over 6 is just x times the 5. We get minus 5x equals, here the x's cancel. You're just left with 1 times 6, which is 6. And after you execute that one step, it's a much simpler looking equation without any rational expressions, no fractions. So we just combine our like terms. 4 minus 5 is a negative 1. Divide by negative 1, x is negative 6. And like I said, oftentimes with these extraneous solutions, you are going to get, or with these rational equations, you're going to get an extraneous solution. So you should plug negative 6 in everywhere you see x and make sure that it works. And here it works. So your answer is negative 6. Example 2, we multiply through by our LCD, which is just an x minus 5. So here the x minus 5's cancel. I'm just left with x minus 1. Here the x minus 5's cancel. I'm just left with 4. Very simple equation to solve. Add 1 to both sides, you get x is 5. But notice what happens here is whenever you plug 5 in for x, you get 0 in the denominator, which we can't have. I don't care if the numerators are the same. You can't have something undefined equal to something undefined. So this is actually an extraneous solution when you get 0 in the denominator. That's the main thing that you're going to look for. So we actually say in this case there is no solution. So always check for that, and mainly you're just going to have to check to make sure you just don't get 0 in the denominator. Example 3. Multiply through by our LCD, which is x minus 2. Here the x minus 2's cancel, you're left with x squared. Here the x minus 2's cancel, you're left with 4. So here we have a quadratic equation. Remember how we solve a quadratic equation? We have to get 0 on one side, so you get x squared minus 4 equals 0. Then we factor it. We can factor this using difference of two squares, x plus 2, x minus 2. And we use principle of zero products to set each factor equal to 0. And then we solve each equation separately from there. So x equals negative 2 or x equals 2. Sometimes both of these solutions work, sometimes one of them works, one of them doesn't, and sometimes neither of them work. And you'll notice what happens is when you check this one here, x equals 2, you get 0 in the denominator. No good. The only solution for this is x equals negative 2. You end up getting 4 over negative 4 equals 4 over negative 4, which is true. So make sure you always check. Example 4. Multiply through by your LCD, which is x. You end up getting x times x, which is x squared, plus, here the x's cancel, just left with 6, equals 5x. So you have a quadratic equation. As we reviewed from example 3, we subtract 5x from both sides. X squared minus 5x plus 6 equals 0. Factor. Factors of 6 that add up to negative 5, negative 3, and negative 2. You end up getting x is 3, x is 2. When you plug them both in and check, they both work. Now that brings us to our last example, example 5. Go ahead and look at warm-up number 3, how similar this is. It's basically the same thing. I want you to notice the difference here because I don't want you doing what we did in warm-up number 3. Okay, you don't need to multiply top and bottom by x minus 5 here. You don't need to multiply top and bottom by x plus 5. All you need to do is multiply through by the LCD, which in this case is x plus 5, x minus 5. That's going to cancel out all the denominators for us. Because we have an equation, we can do this. You can multiply both sides by the same thing. It's still going to balance out the equation. Okay, so basically what this would look like is this. And you don't have to write this step if you don't want. You can skip this step if you'd like after you do enough of these, but that's only if you're comfortable with it. I have no problem with you writing this out, though. Here my x plus 5's cancel. I'm left with 2 times x minus 5. Here my x minus 5's cancel. I'm left with 1 times x plus 5. And here, both the x plus 5's and the x minus 5's cancel. I'm just left with 16. Distribute the 2. Distribute the 1. Collect your like terms. And continue to solve the equation. You end up getting x is 7. If you plug it in, it works. Okay, go ahead and pause the video, work out these checkpoints, see how you can do. Okay, there's your answers to the first 3 checkpoints. Go ahead and pause and see how you can do on D through F. Sorry about that. There are the answers to D through F. Go ahead and check to see how you did. And try the closing questions. First one is 20x squared, and the second one is no because you would have 0 in the denominator. Your homework, if you want to get a head start on it, it is 16 problems, 2 through 28 even, 32 and 34.